Howdy, y'all. This is Vectors Day 2, and I think, y'all, this is kind of sad. I think this is going to be my last video of the entire school year because this is our last unit, and this is my last video of this unit. I don't know, kind of makes me sad. So enjoy it, savor it. If you need to replay it several times, I'll sing a song at the end. Not really. But yeah, just, it's been a journey. So yeah, last week we talked about vectors, and we talked about the fact that vectors have two things that we are really interested in. And let's just draw a quick little vector here. And those two things are, anybody remember? Anybody want to say them out loud? I can tell you're saying them. You are saying direction and magnitude. Remember, we had our little Despicable Me supervillain talking about direction and magnitude. So remember from the last video, direction is the angle theta from standard position. So I'm going to call this direction angle, actually, is what we're looking for there. And even if something is not in standard position, if the vector does not start with its initial point on the origin right there, we want to find that direction angle as if it were starting on the origin. So if I had a vector way up here in the rafters, I would want to say, oh, let me move. Oh, I can't do that. I'm gonna grab everything. Pretend that dot's coming with it. I'm gonna move you down here and find the direction angle as if you were starting down there, right? So direction and magnitude. Magnitude, remember, is just the length. So how long a vector is. So a reminder, that arrow right there does not mean it goes on forever. That just means that's the terminal point of the vector, right? So ten cuidado, por favor, when you're thinking about vectors. So direction and length. So last time I talked a lot about how to find the direction angle using SOHCAHTOA, and finding the magnitude or length using the Pythagorean theorem. And we did a few examples, so if you want to know how to do that, go back to Vectors Day 1. Today, I'm going to talk about doing operations with vectors, so adding, subtracting, and multiplying vectors. So let's take a little sample vector here. We're going to make ourselves a little quadrant 1. And then let's just put our little vector guy right here. Yay. And let's call that vector m. And so let's say I have vector m, and vector m has its fun little direction angle, whatever that might be. And its magnitude is the length right there, which we can figure out using the Pythagorean theorem very easily. Delightful. What if I asked you to find 2m? What do you think you would do? Well, let's do this. I'm going to actually just copy these axes right here. Boop. Did it copy? Copy those. We're going to paste them over here. Oh my gosh, I'm having some difficulty with my iPad. All right, so when I want to find 2m, what I'm doing is I'm just extending the length. I'm multiplying the length by 2, the magnitude times 2. The direction angle is going to say exactly the same. So geometrically, what I can do is I can just take this vector and just paste it twice. I'm going to put the initial point at the origin, and I'm just going to do that one more time, put it tail to tail like so. Whoops, whoopsie doodle. Wow. Let me erase these guys right there. Boom! And that would be the 2m right there, right? And again, the direction angle stays exactly the same. We're just extending the magnitude. If it was 3m, it would be 3 times as long. If it was 1/2 m, it would be shorter, right? It would be cutting m in half, but the direction would stay exactly the same. It's just the magnitude that is lengthening or shortening, right? So I'm not going to ask you to do this geometrically. I'm not going to ask you to do this on a graph. I'm going to ask you to do this using the components, the x and y values of the vectors, the horizontal and vertical components, right? So let's go ahead and write these components. That's 1, 2, 3, 4, 5, 6. So that's 6 down there, 1, 2, 3, 4, and 4 right there. So what I can say is that m is equal to, remember for vectors we use the little pointy brackets. So that's going to be 6, comma 4. So for 2m, y'all, what do you think you do? It is so simple. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Any guesses as to what the y value is going to be? Here we go. 1, 2, 3, 4, 5, 6, 7, 8. That's right. So all I did was take 2 and multiply it times the original horizontal and vertical components. And I've got, oopsie, I forgot my pointy bracket, 12, comma 8. Shazam, that's it. That is my new vector. That's all you have to do, right? Super easy. So that is multiplying a vector by, in this case, this 2 right here is called a scalar. You don't necessarily need to know that, but just in case you hear that thrown around somewhere, that's what that number is called. So multiplying a vector times a scalar, multiplying the vector times a number. You just multiply the horizontal and the vertical components and you will have your new vector, okay? Now, let's talk about adding and subtracting vectors. Now, if we were in real school, we would be doing this geometrically. We would be doing this on a graph and kind of diving into, there's something called the parallelogram method. You are not going to need to know how to do this. Just in case you want to, if you don't want to know how to do this, like skip ahead 1.5 minutes because I'm going to talk about this for just a second. But if you don't want to clutter your brain, in fact, I'm going to write down, you don't need to know this. So the following, you don't need to know it. But because I think it's interesting. So if I was taking this vector right here, and let's make it line up nicely with a point on the grid, and we'll call that vector A. And then we were taking this vector right here, and we'll call this vector, I guess we'll call it B. Whoa, that's not a cursive B, that's a cursive B. Remember, for vectors, we usually use lowercase cursive if we're just using one letter instead of the endpoints. So if I asked you to do A plus B, what you would do geometrically on a graph, which you don't have to do for this unit, so you can skip ahead if you don't want this. What you're going to do is you're going to take A, copy that, paste it, and then you're going to take B, copy that. Nope, don't cut it, copy that, paste it, and you're going to put it tip to tail, like so, kind of worked out there. And then you connect the original with the new end, and that right there is going to be A plus B, that green vector right there. So that would be the geometric way to do this. So you put one vector, you put the initial point of one vector on the terminal point, and then boop, 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 make a new vector out of those. And that's A plus B. So we are not going to do it that way. We are going to do this the algebraic way, just using numbers. So you do need, why can't I write that? It's an N, need to know this. Okay, so if I told you, hey, we'll just use these two vectors up here. Let me do all this in one fell swoop. If I told you, hey, we have vector A, and let's say, so vector A equals 1, 2, 3, 4, 4, comma 1, 2, 3, 3. So vector A is 4, comma 3, and vector B equals 1, 2, 3, 4, 4, and then up 1, 1. And I ask you to find A plus B, right? And I said, hey, whoopsie, whoopsie, find A plus B. All you're going to do, guys, are you ready? Are you ready? It's so, this is the easiest thing we've done all year. You're just going to say, oh, so I'm just going to do 4 comma 3 plus 4 comma 1. And then guess what? You're going to add the horizontal components together. So that's going to turn into 4 plus 4, comma, and then you're going to add the vertical components together. 3 plus 1. So that's 8, comma, 4. Yay. That's it. We have done vector addition. Yeah, I can't, like that. I'm trying to, I want to make it a little bit more difficult, and I don't know. I just don't. I think I'll draw a penguin because that's what I always do when I find myself in a place where I don't know what's going on. So yeah, there you go. That's it. So let's do a vector subtraction. Let's try a vector subtraction. So let's say vector x is equal to 5 comma 3. And let's say vector, I don't know, h is equal to 2 comma 1. And then I want you to please find x minus h. All right, here we go. So x minus h, let's make it a cursive h, is equal to 5 comma 3 minus 2 comma 1, which means 5 minus 2 comma 3 minus 1, which is 2 comma 2. That's all. I mean, holy cow, that's it. That's we're talking super basic mathematics here. So yeah, that's what I got. That's what I got for you. So let's do as one final schmoopty boop, as one final example. I want you to do this on your own and then come back and check in with me. So let's say, God, it's so hard to think of letters. Let's say D is equal to, I don't know, 3 comma 8, and let's say E is equal to 1 comma, oh, I'm running out of room, boop, boop, 5. And I want you to please find 2D, that's right, plus 3E. So go ahead and pause this. Try it real quick. Shouldn't take you that long. Come back. See if you got the right answer. Did you pause? I hope so. I was trying to be frozen for a second so you'd be like, oh, what happened? So y'all, here we go. So we're going to do 2D equals 2 times 3 comma 8. 3E equals 3 times 1 comma 5. So we've got 6 comma 16. And then we've got 3 comma 15. I don't know why I'm making that like a horsey noise every time I draw a pointy bracket, but there it is. So then I'm going to do 616 plus 315. So that means it's going to be 6, whoopsie, plus 316 plus 15, which yields 9 plus 30. Oops, not plus 31, 9, oh golly, comma 30. What, where's the eraser? Y'all, the eraser doesn't work. Oh my gosh. Oh no, the eraser doesn't work. Okay, so my eraser doesn't work. I don't know what happened, so don't do this on your papers. For some reason, the eraser just, okay, I'm not gonna work that out right now. So that is going to be 9 comma 31. Yay. All right. Y'all, that's all I got for you, and that's perfect timing because my iPad is broken. I can't do anything. Oh, it's not cooperating with my camp. Well, that's fun, which is perfect timing because I am at the end of my notes. So you will have a GoFormative on this just check in the calendar, or you can just log on to the GoFormative, and I will be putting up keys to these next week. And then we can talk about tests and all that good stuff. So yeah, it's been real. It's been fun. I'll put up another video next week, just kind of as my last official video, with some stuff about the test and the final and all that good stuff. So be on the lookout for that. Okay, y'all, holler at me if you have any questions, and I will chat with you later. Okay, bye.